solution. We need fans mounted vertically
No.
in there to, or
No.
you got
Could you
fans
repeat
at the
his
top?
question, Bill, so we could hear?
Oh, sorry. His question was, do you need any fans to actually assist the exhaust? Is that right?
Yeah, because you have the potential, if you have a,
You do have the potential to have a little bit of a heat trap here.
you could have a huge heat trap there. You start blowing power supplies, potential.
We've done some CFD modeling as well, where it's actually the bottom third, or less actually, it's like 15 inches.
Yeah.
Where this is mesh. To assist the chipping thing.
So it's not a total solid.
No, we have deployments of both, and it goes to the actual heat range as well. And some of the other pictures we'll see, the whole data center is a solid rear door with a ducted exhaust.
And you're using variable fans on your crack inlet.
Yep.
You can always adjust that to compensate. Or intelligent monitoring actually installed inside of the ducting system to compensate for that static pressure. If it does detect a pressure buildup, it will actually throttle up those fans to compensate for a heat load.
You're actually ducting that out of the room all the way?
Completely ducted out of the room.
That's expensive.
It depends on the methods. If you duct each one with the traditional HVAC, or I've seen people actually have it where it's ducted just into the drop ceiling, and the intake is actually from that. So they're using the raised floor and the drop ceiling both as hot and cold pressure points.
There's actually several methods that you can pump it into the raised ceiling. You can pump it into the HVAC system. You can pump it into the internal facilities HVAC system and use it to heat the building in the wintertime. We're looking at,
It depends, because where your heat return is to your crack is going to be some sort of a balloon or a drop ceiling return. Actually, just remove that and actually create the whole drop. But you have to maintain, you watch where your power your cables are, what their whole heat. So the heat above that is going to be very high. Make sure you have any cables going through that you can sort of loose from there. But if it's managed and thought of on the front end, go that way. So what's you get to each time you can actually slowly adjust your crack accordingly. So it's actually creating negative pressure on the back of the cabin. So we're seeing this as this one, and the next slide is the next trend. This one is what we're going to call just a plein air, raised floor ducted to the front of the enclosure, and a ducted exhaust. So you still have a vented front door and a solid rear door. And still with a fan assist if you want. All with the redundant intake, redundant power. But what we're seeing now, when you're able to do this, your chilled air does not have to actually cool the room. This is where the simplest cost-effective way to do it, where you can keep your crack unit either the same, achieve a higher density. You don't actually have to chill the air here. It actually helps you get some here. The pressure from the raised floor, the floor tile. Right now we're using perf tiles where it's here, and we're hoping that the chilled air comes all the way up and isn't sucked in through the mesh as well. And the fans on the server actually have to create that pressure, negative pressure to pull through on all their traditional hot out, cold out concepts. What we're now is ducting just by very simple methods. No fans, it's actually just using the pressure of the raised floor, ducted right to the front space between the air intake and the servers. And behind the mesh door, we're seeing some people use clear plexiglass with just a perimeter vented, just a little assist as well. Do some mixing of that. What this does is it gets you the increased white space temperature. So you don't have to actually have your crack unit cool the whole room. I only want to cool my equipment. I don't want to cool the whole room at 65. I can I'm fine at 72, but the equipment I want to have the greatest delta T going across it. So the 68 and 72 in the white space, which means I don't have to actually have to cool the whole room. 60 to 65 now is what's under the raised floor. It doesn't mix with the ambient room. It actually is ducted right into the enclosure, right to the intake. And still with the same exhaust. You really don't want to go over that too much, and the same method of ducting it out. So now, this method, there is no hot out, cold out. You're just actually cooling the room to where it's suitable for a person, and all the air is actually ducted through the enclosure. So it's basically part of the HVA system. We're seeing the approximate kilowatt loads, 8 to 12 with this. Some of them are actually being very conservative here. The return air temp is increased. That's what we said before. Less perf tiles are required to cool the white space only. The intake air is forced through an adjustable air diverter directly from the crack. Whenever you have a ducted system on the raised floor, when you start cutting holes in the raised floor, you want to maintain the same pressure throughout your data center. If you cut the same hole everywhere, you're going to have pressure drops, where some of actually are going to be pulling down. We've seen that as well. So you have to maintain how close you are, what the velocity is underneath. So on a cabinet far away, you can have to adjust your opening to maintain your pressure throughout your data center. So that's one thing that is critical, that when you start cutting holes in the raised floor, some of the perf tiles, you can adjust how many perf tiles you have. That works as the same way as this adjustable ducting system. Maintaining pressure. Yeah. Well, and the last one is actually just following the laws of thermodynamics. Cool air dropping, hot air going out. So, ducted intake, ducted exhaust. And this can be done on a concrete slab floor if needed. And you have no need for an under-raised floor. But this would be a full build. What happens here, you solid front door, solid rear door, 68 to 72 in the white space, basically your own space. Now you actually can get the exact same temperature coming out of your crack. Sure.
Talk about that you're going to cover these inside your products so you guys know what you're pretty much talking about. Are those ducts expandable?
We make
accordion style, or we have solid.
We have an adjustable chimney that covers a range, but we make a lot of custom parts as well. What we're seeing is each week, a lot of the data centers are an old warehouse being retrofitted, or something being built brand new, or whatever the manager wanted to have at the time. We've seen 7-foot chimney, 16 by 18 by 7 feet, and the last 6 inches is adjustable. So yes, we're definitely seeing it. And some of them actually are where it's a brush grommet where it seals it. Some of them are actually ducted and cut where the ceiling tiles are cut around each gym exhaust chimney. So yes, try not to be too product specific, but just going over just methodologies, concepts to think of, and then we can get into specifics. That's one of those. But we're seeing there's a couple data centers that are built like this that we've read about and seen, and actually we have a couple products. Every cooling product that I've shown is upgradable. It's not, you don't have to buy a new cabinet. So there are things that you can, very simple, cost-effective ways to manage the heat load without buying a whole new product, a whole new cabinet, just by sealing the gaps, as we say, and managing the power. So within this, this would be ideal. This is basically a ducted system to your HVA system, to your vacuum system. There are very little perf tiles at all, if none.